5.9 is going to solve one of the problems mathematicians have. And if you remember, we have said to this point that the square root of -4 is no solution. Well, that's not exactly true. What it is it's no real solution. Mathematicians don't like unanswered questions. And so what has happened, if you look at this little history, math history, consider the equation 2x squared plus 2 equals 0. If you solve it for x squared, the result is x squared equals -1. There's no real number whose square is -1, so this situation over here. So there's no real solutions. However, a French mathematician by the name of René Descartes proposed that the number I be defined so that I squared equals -1. So this is really a new math fact for you. It's kind of like learning 2 times 2 is 4. The converse of this is saying that the square root of -1 is I. And these are the two new math facts that you need to learn. So what does this mean? Again, anything with an I is going to behave almost exactly like a variable. So we're going to go ahead. Now we can solve this, and we want to think about this as -1 square root times 28 square root, because we know that we have that rule that says that we can split a root. So the square root of -1 is I. Are there any perfect squares in 28? Well, 28 is 4 times 7. So the square root of 4 is 2. 7 is my leftover. It's good math grammar to write the real number first and then the imaginary part. And that's your answer. So really nothing is changing except now I have the square root of -1. So here I'm going to say the square root of -1 times the square root of 32 times the square root of y cubed. The square root of -1 is I. The square root of 32, well, that's 16 times 2, so the square root of 16 is 4, and that 2 is a leftover. Y cubed is really y squared times y. The square root of y squared is y, and I have 1 y left over. And when I clean this up, I have 4y I square root 2y. And that is your exact answer. Now multiplication is exactly like it would be for variables and exponents. When I multiply, I get exponents. So the real part, -3 times 2 is -6. I times I is I squared, but I know my math facts that -6 times I squared is -1, and so the answer is 6. In the same way here, I have -1 times 4 times 3 for -12 times the square root of -1 times 2. So when I take the square root of -1, I get I. The square root of 2 is 2, or 4 is 2, excuse me. Square root of 3 is a leftover. The square root of -1 is I. The square root of 2 is a leftover. So those all go under the radical. When I simplify, I have 2I squared times the square root of 6. Well, I squared is -1, so I have -2 square roots of 6. And that is the lowest terms. Simplifying powers of I requires a little bit of finagling, and again, going back to our rules. So I'm going to think of this, if I want to think of groups of I squared, because that is -1. There are going to be 4 choices. when we take I to a power, we're either going to end up with I, we're going to end up with negative I, we're going to end up with 1, or we'll end up with negative 1. And those are the only 4 answers you can get when you take a power of I on its own. So what you want to do is kind of start breaking it down in a way that makes sense to you. So when I see I to the 35, I see I to the 34 times I. Well, why do I go to 34? Well, I know I can write that as I squared to the 17th times I. Well, I squared is negative 1 to the 17th power times I. Well, what is a negative number to an odd power? It's always that negative number. And so this works out to be negative I. Now when I think about 57, I think about I to the 56 times I. I still have 57 of them. Well, this time I squared to the 28 is how I get 56 times I. So now I have negative 1 to an even power times I. Well, a negative number to an even power is 1, and I don't need to write that 1, and so my answer is I. When I have it to an even power to start with, now I'm going to think about, well, this is I squared to the 32nd, which is negative 1 to the 32nd. So I have negative 1 to an even power, so that is 1. In this case, I have I squared to the 21st power, so I have negative 1 to the 21st power, a negative number to an odd power is negative. So that's how you're going to figure out which of these answers is your appropriate I, negative I, 1, or negative 1. Now when we're solving these with exponents, we're going to go ahead, same rules apply, solve for isolating the variable. So first, I'm going to subtract 20. So I have 5y squared is equal to negative 20. Nothing has changed. Divide by 5. Y squared is equal to negative 4. How do I undo squaring? I square root both sides, and so y is, now this is in the past where we would have said no solution, but now since we have imaginary numbers, we can see this as negative 1 times 4 under the radical. The square root of negative 1 is I, the square root of 4 is 2. And when we take the square roots, we know we always take plus and minus of those values. Now when these imaginary numbers get mixed with real numbers, we end up with a complex number. A complex number is any number that can be written in the form a plus bi, where a and b are real numbers and I is imaginary. This a thing all by itself is the real part, and b is the imaginary part. And you can kind of see where that makes sense. This is the real component, this is the imaginary component. Again, real component, imaginary component. Okay? Now, just a little, math background. The Venn diagram at the right shows the complex number system. If b equals 0, the complex number is a real number. So if you think about a plus 0 times I, I'm left with a, which is real. If b is not 0, then the complex number is imaginary. Then this bi part will exist and be imaginary. if a is 0, 0 plus some bi, all I'm left with is the imaginary part, and so that's why that becomes an imaginary. So you really have the imaginary dropping out, becoming real, both of them existing, becomes complex, the real part dropping out, and you're left with just an imaginary number. Now, in order to solve mixed problems like this, where I have real components and I have imaginary components, there's a neat little trick. I can take the two real components and set an equality sign up and solve for them. 2x equals negative 14. And I can set up an equation for my two imaginary parts. Y times I is equal to negative 3i. And I can solve. Now this is our normal run-of-the-mill solving, so I would subtract by 2, and x is equal to negative 7. Here, I'm going to divide both sides by I and I cancel, and y is equal to negative 3. And that is how simple it is to solve for two variables with two complex numbers. Now, operations with imaginary numbers, again, are just like variables. So if you can add the numbers, you can add imaginary numbers. So here, your real part and your real part are going to be added. This is not a distributive property. Your imaginary part and your imaginary part are going to be added. And that is all there is to it. So if you're stuck, think, what would you do if this said 3 plus 5x plus 2 minus 4x? That was your little thinking to yourself. That's exactly how you would handle an imaginary part. Here with this minus, be sure to change that to plus a negative 1. Distribute that negative to both pieces, so I have 4 plus negative 6i plus negative 3 plus 7i, because this was a negative. Negative times a negative is positive. Now go ahead and put your two constant parts together. 4 plus negative 3 is 1. Put your two imaginary parts together. Negative 6i plus 7i is plus 1i. And that is your complex number. Part 2 of the video will talk about how to multiply and divide complex numbers.